you, Josh. So I'm going to talk about beyond infrastructure as code. Infrastructure as code is great. It's probably the best way to define your infrastructure, and it's really carried us over the last 15 years or so and allowed us to really mature in the DevOps and deployment space. Gave us a whole bunch of different things. But today I'm going to be talking about a tool called System Initiative from a group of people who thought maybe we can look at the problem and define some new building blocks and potentially improve the way we could be declaring our infrastructure. So keep an open mind. This is definitely stuff that is coming, like the product is being built, and it really, I'm not sure everyone will be ready to adopt it and kind of get it yet. But start thinking about it, because for me it's been a really eye-opening experience and one of those times where you're like, this could be amazing for all of these reasons. Bit about me, I love doing conference-driven development, so I jumped in about a week and a half ago for Lars Klint, and System Initiative's been on my radar for quite some time. And I really wanted an excuse to dive in and really understand and learn the tool, so that's why I'm here talking about it today. I'm a principal consultant at Arcana. We do a couple of things. We've got product, a managed service offering, and like a lot of focus around platform engineering, repeatability, and those sort of things. So if any of those are interested to you, come talk to me after. But it's my want to kind of improve this space and really understand everything that's on offer that's kind of driven me to learn this. But first I want to take a step back. Can anyone kind of put your hand up and say why we're trying to do this DevOps thing? Like, what's the point of it? Observation? Yeah. So for me, the simplest way I can say it is about tools and techniques and practices that allow us to improve the flow of our software into production and operate it reliably. So it's about flow of value into production and being able to make sure there aren't problems. That's the simplest kind of definition I can come up with. And there's kind of three aspects that we deal with. There's the infrastructure side, which is where the infrastructure as code lives. There's your application code, which sometimes can go into your infrastructure as code, but often is deployed into the infrastructure outside of that. And then there's the operations side. So if we start just by focusing on the infrastructure with infrastructure as code, it has been really successful. Like, infrastructure as code has allowed teams to become more consistent, repeatable, automation, and really improve their kind of like practice around getting their software into production and not having drift across different environments and a whole bunch of benefits that we all probably know about versus, say, ClickOps. But the reality is infrastructure as code is really hard. It often is orders of magnitude more effort to get something up and running using infrastructure as code as just like next through the ClickOps way. And if we have a look at the DORA State of DevOps report, it kind of shows that as an industry, most people don't get to, like, if you're on a team that has nice CI pipelines and all your infrastructure as code, most people don't get there, and that's sad. Like, there's a whole bunch of these metrics that they measure in the State of DevOps report. But if we have a look at how people are doing, these are the people who are measured. Over 60% of them are in this can't deploy more than once a week. And as an industry, we can do better. And that's what the guys at System Initiative are kind of trying to do. So let's have a look at what makes it hard. Infrastructure as code is a desired state management tool. What that means is we've got our Terraform, Pulumi, Bicep, whatever you're defining it as, generally hosted in GitHub or whatever your source control is. You've got some pipelines, and the job of these tools is to make whatever your desired state is in code to make your cloud environment look like that. That's what these desired state management tools are doing. But there's some challenges, like design and collaboration. Collaborating over these bits of code across all of these files, they're not particularly friendly to that. So if we're defining the infrastructure for a new project, we often reach for diagramming tools at the start. So Miro and collaboratively build out what our infrastructure will look like. And there's a bunch of them. And then once we're happy with that, we go and implement it in our infrastructure as code tool. So this is kind of our flow around collaboration, and if we need to make large infrastructure changes, we normally do that over our diagramming tools, not looking through a bunch of Terraform files. Getting updates in, it's also a bit of a clunky process. It's the best we've got, but damn animations. We've got Terraform and then GitHub. Push that to GitHub, open a pull request. It runs maybe a plan or a Pulumi preview, shows you these are the things that are going to change. Yep, that looks right. Merge it. That runs your main deployment pipeline on main, pushes it to Azure. Boop, some sort of policy or invariant, or you're not allowed to rename this particular resource, or any number of problems that can cause the apply to not match what happened in the plan. So updates are sometimes really frustrating because they kind of say, but the plan worked, why didn't they apply? There's another issue around this 200% problem, and you see this with if your team is using a particular infrastructure as code tool and someone new comes on, they've not used that tool before, but they know AWS or Azure really, really well. They have to learn this whole new tool, ecosystem, DSL, how this tool works to be able to be productive again in a tool that they already know, in a cloud they already know. And there's often an impedance mismatch around like what the resources are called in the particular Terraform or Pulumi provider. This property is called something different to what it's actually named in the cloud. And there's this duplication of kind of understanding. You really need to know both tools to be able to use either of them, which is kind of frustrating. And you see this in more traditional ops teams. One of my teams, we moved from Terraform to Pulumi. And with that, we had a look, and there was a real worry about moving from Terraform to Pulumi because I've got to learn this new coding language. So it kind of shows how much investment people have in these tools. And finally, some things can't be modeled. What about if you've got a load balancer and you want to do like split traffic? How do I model that I want, when I do the apply, I want 10% of my traffic to go to this instance, and then once it's had 10 minutes without any new errors appearing, move everything across. It just doesn't work in a declarative state model. You can't do those sort of things. Also, you've got numerous sources of truth, and we've all seen when you're if someone's click up something that's got out of sync with the state and having to import into your state. It's a bit of a nightmare because at the end of the day, you want your source of truth to live in Git, but the reality is your source of truth is your cloud deployment. So with all of those limitations, have we hit the limit of what infrastructure as code can do for us? And that's what the system initiative guys are trying to do. They're trying to take a step back, and can they build something? This is what system initiative looks like. It is a diagramming tool that allows, I'll blow it up in a minute, this is quite small, but it allows you to model your infrastructure as, allows you to model your infrastructure in a diagramming tool, so there isn't a translation layer. And you might be thinking, oh God, another infrastructure diagramming tool. We've all been there, we've all tried them, they generally suck. A lot of them are just abstractions over the tools we have, like drag and drop, and then it drops a bunch of Terraform or Pulumi or whatever out, and then that's the engine that applies it. System initiative is quite different to most of those other tools that you've seen, and it is the building blocks, it is the engine. You'll see how that kind of affects things. The basic building blocks is you have assets. Each of these boxes in system initiative are an asset, and you can join assets together. So if you have a location and you want to deploy a log analytics workspace to that location, you can join those two assets together. Some assets are real, like they represent things that are real cloud like resources, and then others are more kind of virtual things that you theoretically model. The great thing about this is then it builds up a graph of these assets and edges. So there's a few talks today that mentioned graph theory, and you've got your nodes and your edges, and everything in system initiative is a graph. Each of those assets then define a bunch of functions. So a create function, a refresh function, a delete function, and a whole bunch of other things like management functions to be able to import. It's completely extensible. You can just attach new functions to any of these assets. What's really cool about that is the management ones, if you had a VM, you could attach a management function that restarts the VM. So now we start having not just infrastructure as code, but you start blending into the operations side, which is pretty interesting. But then we introduce these problems of collaboration and versioning. So built into the tool is the idea of change sets, where you can make changes to your diagram. It creates essentially your branch, and then it tracks all of the changes that you've made on the branch. They use non-conflicting data types under the covers, which is really, really cool. So you can collaborate. You can then run qualifications over your entire graph. So qualifications, for the example of an Azure location, is it calls the Azure API to make sure that the location that you've entered is a valid location for Azure. There's a whole bunch of other things you can do, like AWS policy simulators, Trivy for scanning, anything that you could feed the model into that can validate what your cloud should look like can be put into one of these. You can just make API calls, run CLIs, whatever. As long as it doesn't run against the actual infrastructure in the cloud, you can validate your model at full fidelity. It's also fully extensible. You have these assets, and for my demo, System Initiative didn't actually support Azure, so I modeled out building a container app environment in Azure in System Initiative. And as I said, I picked up this and started using the tool for the first time about a week and a half ago. So I've built the talk, learned the tool, and modeled out how to build all this stuff in Azure in a week and a half in my free time. So pretty cool testament. Like, I wouldn't be able to pick up an infrastructure as code tool that I know and be able to implement all of these resources in that. All of these, any resources provided by System Initiative or whatnot, you can just edit them and make changes. So everything is open source, and then once, if I want to contribute back, I've made changes, fixed some bugs, added a new property, I can just hit the little contribute button, that little cloud button, and contribute that back. The System Initiative team can then put that back in the asset list for everyone to share those updates. So it kind of has this open source and collaborative vibe as well. Another really cool aspect is it's multiplayer. So here is a little bit of a video where it's got two browser windows open. You can, just like Miro, you can all be collaborating over the diagram, and you get live updates across everyone's instance. So you can be on a video, like just a call, Teams call or whatever, and people can be collaborating over this infrastructure diagram. And when you're ready, yep, cool, we'll just apply that to production, and it pushes all those changes. Really, really cool. And then once those changes go in, all of the other change sets get rebased on top of it, which is another really nifty thing. I talked about qualification functions earlier. If you can write it or call a CLI to validate it, you have a full fidelity model of your cloud environment. So you can start testing all of these theories about what happens if I structure my application like this. Can this container talk to this database? Does it have permissions? As long as you can write a little function that does that, you can put that into your assets and it manages it. So I'm going to give you a quick demo of System Initiative. So this is what System Initiative looks like. You've got a canvas with your various assets, and you can drag things on. So in here, I've got an Azure naming resource, and this is a virtual one that I need to not be zooming. Okay, so I've created an Azure naming. This is a typical problem where you have, you want to make resources conform to a standard. There's two types. You'll notice like resources can be nested in each other. Here, you've got different types. So I'm going to change this one to a down frame, which means other resources can be nested inside it. That means my naming convention can be applied to things below it. I'm then going to search for a resource group and put the resource group inside it. Then updating my model here. When it finishes calculating the model, I can select it, and you can see it's calculated the name of that resource using Azure naming conventions because I've put that resource inside that. It's automatically created a change set for me, and I can apply that change set, which will create this resource group. So I can go and hit that and apply the resource group. I said that it allowed customization. And so if I go in here and my resource group, there's something I want to make changes to it. This is how a system initiative component is written. You have properties, and they are defined as builders, and you've got functions. I can just edit this function, make changes to its definition, and once I do that, I can jump back to my model, and you'll see here that I can upgrade my model to my fork of that function. And all the included assets can be done and modeled as well. So pretty cool. And then you can refresh the state in your environment to mirror, so it's two-way. So to wrap up, there's a couple of things. We've got assets, connections, and a hypergraph of functions. It is completely open source. You can host the entire SaaS product yourself. It's only protected by trademarks, so you just can't call it system initiative. Customizable, extensible, allows you to model digital twins. There's a couple of other little things. It's not just infrastructure you can model. What about user account creation in all of your tools? You could create a user, and then you could model that user having accounts in all of your different tools, as long as there's an API. So to get started, have a look at their website, systemandnit.com, and have a play around, because it's pretty cool stuff. As I said, one of the products I kind of do is feature board. I've had a lot to do with that. We are doing 50% off, so if you want to have a look and at feature board and try it out, scan that QR code. But I think we've got time for a couple of questions.
Yeah, definitely got time for questions. Yeah.
Do you know if it allows importing existing resources?
Yep, really good question. So their system initiative definitely is in progress, but you can create import functions on there, so management functions that allow you to import specific resources. But one of the goals is to be able to create just be able to import, say, a subscription or an AWS account, and it can go and create you a model, which then you can take it from there. And that's the real power. That rebasing functionality means that if changes are happening to your environment and you're making these speculative changes, you should be able to import any changes to your underlying model. And because it's non-conflicting data types underneath, it can replay your model changes on top and then run all your qualification functions to see if it is still valid after it's had a look at the actual state of the cloud. So the goal there is definitely two-way full fidelity. Yep.
Thanks, Toby. Does this system initiative output like some code artifacts? For example, like if today you've got your state of infrastructure in AWS, but you realize there's something wrong and you want to do like a git revert to how it was last Monday, or you want to cherry pick something from a specific SHA and bring it into however system initiative is right now?
Yep. So you've got two parts of that. I'll tackle the asset side first. So everything in System Initiative follows like that Git graph model. So every asset has its own version. So you can go back to, like, if you adopt a new version of an asset, that only affects your workspace and you have to explicitly opt into updates. So if there's like a new functionality and you adopt an asset that causes problems, you can go back to an earlier version of that asset in your workspace. The other side of it is your entire environment. So snapshot, there isn't such, not that I'm aware of anyway, you've got an audit trail of kind of all changes that have happened to your model, but it's kind of got the revert functionality is, this is what I want it to be, I'll undo the changes in my model, and then it will go reflect those changes. So there's not kind of the same benefits I get of reset to a SHA, because it is a two-way live model. So the same concept like can't really exist. It's also really early. So I know that a lot of the history and that sort of stuff and visualizing those changes over time are just features that are probably coming soon. Like they've only introduced a couple of weeks ago RBAC support to be able to do it. So there's still a lot being built out.
I suppose there's a bit of an add-on to that last one. If you mentioned multiplayer, but what about collaboration where you're not working at the same time and you want to merge two branches of changes?
Yep.
And how is it stored separately to your actual infrastructure? Is it similar to Terraform where it's got a state?
Yep. So the way it works is you have your workspace, and your workspace has a change set. So it'll be the head change set. All of those resources will have an understanding of what your cloud infrastructure is at the time. So they do, at a resource level, have state. And so if two people have a change set at the same time, and you kind of move forward, and then you apply that change set to head, the changes you've made in this change set will automatically get rebased on top of head. And then because it has an understanding of the graph, when it tries to do the calculation of the changes in your model, it knows every asset in your graph that could be affected by your change. So it can automatically enqueue refresh functions for any impacted things, which will go fetch the state from your actual environment to make sure the model for anything you're touching represents reality. So when all of those qualification functions run, they are running against as close as possible. So the equivalent would be I rebase and do a Terraform refresh every time I rebase and refresh my state, and all of that is happening behind the scenes automatically for me. So there's a lot more going on, and it's a lot more powerful because of that underlying model. The other really cool thing, talking about the collaboration and multiplayer, we've talked a lot about AI. There's nothing stopping an AI agent being one of those members, and you're collaborating with them and asking them to update your model, and they're going out and building things, because a lot of these resources in System Initiative, they've used AI to go read the docs and generate all of the props, because they read a bit of the CLI docs and various other things, pull it together inside these assets. So that model enables some really cool collaboration aspects. I think that's probably it. One more? Yep.
Yeah, I'll
go.
Go. Mike, so I'll take it. Is there the ability to sort of exclude things from being configured within it? And what I mean by that is, say you have a resource group, and within that resource group you want it to be a free-form sort of space that people can do things, but you don't want to adopt those changes that they're making in that space. And you probably know from our use case exactly what I'm asking.
Yeah. So I think that's where there's two aspects. There's the RBAC side of making sure that people that aren't allowed to touch certain parts of the model are allowed. But then there is also your change set, and it will show you all of the actions, and you can put specific actions on hold or remove them. So when you apply the change set, you're in full control of which parts of your model changes will actually make changes to the real world. So you kind of opt into, if you've added 10 resources, but I just want to create this one, you can remove the 9, and then when you apply that change set, only that one gets configured, which is really, really cool. The other thing it made me think of, and I'll kind of use this as a tangent, is because it's a model backed by a diagramming tool, let's say you just want to remove all your IAM stuff, you can select all of that, move that to an IAM role, and now you've got different views over the one model, which is really cool.
Awesome. Thanks, Jake.